obviously very serious and pressing issues that are facing us and have been facing us and will continue to going forward. And the title I was given is Eco Crisis. I'll address that. I'll talk about climate change, focus more regionally, and I spend a lot of my life. I've done the reverse of what faculty often do is I've started out very broad, global and national, and increasingly in recent years focused more and more specifically on Maine, where I'm from. And I realize we have folks from throughout New England and I think some New Brunswick potentially as well in our Canadian neighbors. So without further ado, if I can get this, I made my cursor big for this. There we go. You know, why are we having an eco-anxiety webinar? Why, you know, what's the issue? And obviously everyone on the webinar tonight knows what the issue is. I just thought I'd start by kind of reflecting on examples of what we're thinking about or talking about, depending on what you're experiencing and what you're involved in. On the climate side, as we've heard in the past couple of weeks, and you see all around us in news reports, we're on track for another record year, warm year, and we've had plenty, and we'll see that in the plot in a couple minutes. We've got a drought going on in parts of New England. Droughts are complex topics, but there's lots of areas that have received very little rain and are suffering from it. We're on track for a record hurricane season. We've got fires in the US West and Australia and the Arctic, flooding in coastal regions as well as in riverine systems, rivers. Global biodiversity is in decline. A couple of years ago, the counterpart to the global climate group, the Intergovernmental Panel on Climate Change, there's a global intergovernmental panel that deals with biodiversity that issued a major synthesis of their work and talked about different percentages of decline of lost species, both extirpation, meaning lost from particular areas, as well as extinctions. And you've probably heard the referral to the sixth great extinction. So the biology and the ecosystems that we live in, are part of, and support us are in decline. And a lot of the climate side is, of course, influenced by increasing greenhouse gases, which is driving most of the climate-related signals. In addition, we're living through a remarkable, not in a good way, global viral pandemic with COVID-19. We've got an economic recession. We've got bubbling to the surface the public expressions of protest over the racial and social and ethnic inequities that we see all around us and that are accentuated by these challenges. Record unemployment. I'm at a university and I've got grandkids going to school next week and the week after that, and all of you that have children and those that don't as well, I know, are extremely concerned and somewhat baffled by the complex systems that we face now to try and simply educate our children and allow them to go to school and have the important socialization that much as I appreciate being part of this, that you can't do with Zoom. And so tremendous challenges, particularly this year. And then Diane talked about many aspects of the emotional and mental health, certainly the isolation that elderly and people in need and people with medical conditions and what have you are dealing with at heightened levels. So that's a lot of doom and gloom, and it's all real. It's not hyperbole to say this is a transitional year in 2020, in my opinion, and that we are in a unique period of time for our planet, our society, our species, as we move forward, not on a decadal or a century basis, but on a monthly and yearly basis on the decisions that we're we're making, and we can't go backwards. We can't recapture the past. We have to go forward. So that's why we're having this discussion. And we'll talk a little bit about climate. I'm not going to get into the biodiversity as much tonight, and then we'll talk about where we go from here. These are NOAA year-to-date global temperatures. These are about a dozen years. You can see over here in the legend that they all have twos in front of them. That's because all the hottest years on record occurred since the year 2000. 1998 is a straggler there, and I think, and this is the top dozen, so it will be kicked out of the top dozen. It's already out of the top 10. And 2020 is on track to be, it's just slightly less than 2016 up till June. But there's reason to believe that it will overtake the cumulative heat record to be the warmest year on record this year. And while normally we, in the world we've left, we would say, wow, that's amazing. It was a really hot year. But we have this experience if it wasn't last year, it was 2 or 3 years ago. But we're constantly breaking records for the hottest years. And so this is an experience that will continue, reflecting the changing climate. Oop, what did I do? I want to talk a little bit about terms, terminology, just not because they pay me to be a professor, but I think it is important to visit these concepts. The first one is climate. We're talking a lot about climate. Climate, as you've probably already heard many times, climate is not weather. Weather is what we get today. Climate is what we expect tomorrow, because it's some sort of a norm for the area that you're in. Meteorologists usually use a 30-year average for climate. So when someone says, or you read something about, in this particular area, they get so much rainfall and the average temperature is X. Those are usually 30-year norms. And they move every 10 years, meaning a new 30-year average is sort of calculated and is used. That's the climate. And obviously it's not stationary. It's a moving system, but it's also not weather. And weather is the very short term, what we experience. Climate change describes simply a change in those statistical norms. And essentially every time they are recalculated, they change. And in the last half century, almost always the temperatures going up. And for us in the Northeast, precipitation is going up. Most of what we think of for climate change in that regard, it has to do with these norms of temperature and rainfall. And then finally, climate change that I sort of put in quotes, global change is probably a better term. We've had global warming, climate change, climate warming, global change. We've bounced around, we being sort of society, the scientific community, the political community, with various terms. I think we're sort of using most frequently the term climate change, and not like the technical climate change in number 2, but the broad climate change having to do with all of the changes that are associated with particularly changing greenhouse gas emissions, CO2, carbon dioxide particularly, but also methane, nitrous oxide, and a number of other relatively potent minor gases. And so this climate change is really what we're talking about. It encompasses air temperature, ocean temperature, precipitation, storms, ocean acidification, sea level rise, melting ice, losing winters, ice storms, hurricanes, heat waves, and then often, I shouldn't say sometimes, here often, the host of effects that all of these various changes, singularly and in combination, bring us. And this change is always in concert with all of the other changes taking place in our world. So it's this complex climate change, I think, that we are all particularly reacting to, because every facet of who we are in our society is impacted by the changes that we're seeing. I'm going to use this panel from the National Climate Assessment. That's the United States assessment, comparable to the global assessment that's done by the Intergovernmental Panel on Climate Change, and I'll come back to them in a little later. But I like this for a few reasons that allow us to take just a couple of minutes to talk about the complexity of changes taking place. The figure here does a nice job of pointing to various aspects of the climate system, but then also various aspects of the ecosystems that include us and how they react, or the fact that they react and interact with the changing climate. So this kind of context of climate change is complex. And if we can kind of walk around this set of figures, these data, I like to call them dashboards. We do have warming temperatures. We're going to come back to that map in a minute, so I'm just going to go quickly. You have increased heat waves across the country. These are hot days, and when you add to that humidity, then you get high heat index days that I think Diane talked about a bit last week, that have particular impacts on human health. Increased precipitation, heavy precipitation events, intense storms, snow, but particularly rain events is what people I think most think about. And again, I'll have more to say in a minute about that relative to the Northeast. Changes in the snowpack. These are the Western Snow Survey, which has been, is usually where a lot of the attention is placed because a lot of the hydrology, the water sources for the Western United States are dependent on mountain snows in the Rockies and high elevations, the Cascades. And so the less snowpack, or the loss of snowpack in the mountains, means that as they melt, the recharge of water supplies for many of those otherwise arid regions are diminished. This actually is a really critical issue in Asia, where we talk about the loss of the water tower, which are high elevation mountain glaciers and snowpacks that essentially are the primary water supply for much of civilization that lives in portions of that region. And it's decreasing as glaciers melt and as snowpacks change. We are in the past few years just beginning to really focus on how this is expressing itself in the Northeast. There's a lot of interest in, I think there's a group called Losing Winter, and some recent studies that identify the changes that we're seeing, and I think probably everyone on this webinar are experiencing. U.S. drought conditions are actually more complicated. I got to stop doing that. What drought is more complicated. There's agricultural drought, meteorological drought, hydrologic drought, etc. But it doesn't have to be technically a formal drought for short-term moisture deficiencies to create dry conditions that are a problem. And we see that a lot with soil moisture deficits, because the temperatures are getting warmer. Even if you have the same amount of rain, you evaporate more water off, and that stresses the ecosystems, the crops, the forests, and the water supplies. Arctic ice, you may hear spoken about a lot, and obviously that's not in the Northeast. It's not even most of it in the United States, except in Alaska. But it's so important because of how it impacts the weather systems that impact us in the Northeast, and the impacts on the jet stream and the retention of energy as we lose. The core of this, as you lose the ice cover of the Arctic Ocean, it reflects less, it absorbs more energy. It therefore transfers more energy, and it changes the jet stream, and we experience that. I have to apologize every now and then. You may hear noise in the background because they decided to pave the road outside this university building today. Sea level rise speaks for itself around the planet. sea level is rising and having a tremendous impact because we like to live along the coast and develop and invest and build. And so that impact is already real and will continue to be an increasing concern. I've got to move that. There we go. Marine species are responding to the changing temperatures of the water. And certainly in the Northeast, off our coastal waters, fisheries, we're experiencing that. Some of that is increasingly suspected to be contributed to by ocean acidification, which I often have. There was a slide on talks that I give where I talk about all the climate indicators without the ocean acidification, and then say that we're just beginning to have data in this region. But if the only issue we had was ocean acidification, the world would still be in a crisis. Ocean acidification is when the CO2 from the atmosphere dissolves in ocean water and makes it more acidic. And a lot of the biota, particularly organisms that build shells, because they build shells out of materials that are built of calcium carbonate and dissolve in acids, and they need to spend more energy trying to do that, and in some cases will not survive. The warming is giving us longer growing seasons, which in some cases is good. In other cases, it's brought additional problems, but it's very real. We've got about 2 weeks more in the Northeast, 2 to 3, with probably about the same expected by mid-century. Wildfires, we're pretty humid in the Northeast. We do have wildfires, certainly, and we're having more than usual this year because of the dry conditions. We typically don't have the kind of fire issues that we see elsewhere, and certainly when they talk about U.S. fires and you see this curve going up, that's a lot about the Western fires, often mega fires that we see burning as a result of the warming climate and the lack of moisture, as well as other factors that contribute. But clearly we've migrated to more and bigger and more intense as a result of the climatic signal that's part of it. And then the last is related to these other things. Heating and cooling days. Obviously, we spend less money and energy on heating and more on cooling as the climate gets warmer. So the take home here is simply there's a lot of facets to what we're talking about as far as climate change and global warming than just the warming of the atmosphere. And we're experiencing it around the world. We're experiencing it at the national level, and certainly we're experiencing it in the Northeast. To focus a little bit more on the Northeast, we're still going to show you a national map. But this is that map we just looked at. It's showing the observed temperature change, the most recent period of 30 years compared to essentially an average across the last century. So this is not a 30-year average. This is a 60-year average, pretty much. And it shows the areas of the country that have warmed the most. And so this is, if it's on this side of zero, it's warmer than it used to be in the last century. And if it's this side, it's cooler. And it's just very little area in the southeast that is cooler, but clearly the north and some of the western areas are definitely warmer, some significantly warmer. And obviously, we in the Northeast are part of that. If we look at what we expect, and so these are predicted temperature changes by mid-century, so think 2050, compared to the 100 years or so before that. And the map on the left is sort of the moderate warming scenario. The map on the right is the high warming scenario. These numbers, you may be familiar with them, but if you're not, it's not important. These stand for a representative concentration pathway, and then that's the warming in watts per square meter that you get from that. These we take from the IPCC. They have low 2.6, medium 4.5, and then high 8.5. It's worth noting there's sort of controversy on how this terminology is used, but to date, we're pretty much on the high scenario, the amount of greenhouse gases we're emitting. And so, you know, the best available models are predicting this is what we're heading towards, which is obviously significantly more warming in the northern areas, certainly particularly in Alaska from Arctic amplification. We expect to warm significantly if we kind of get our act together and reduce greenhouse gas emissions fairly aggressively. We'll get, you know, 2 degrees to 3 degrees more warming rather than 4 or 5 going forward. By the end of the century, we see that the warming, not surprisingly, continues with 4 or 5 degrees in the Northeast under the moderate, and up to 8 degrees Fahrenheit, give or take a couple of degrees in the northern states and in the Northeast. That's a lot of warming, and that's the trajectory that we're on right now. This is now I'm going to show you a few figures of precipitation. So this is the amount of rain, not just rain, the amount of precipitation, rain, snow, everything that's when melted is wet, that we have in our weather system. And again, the most recent 30-year mean compared to the last century. This one's a little more shifted towards the big increases are up here in the north central and the northeastern states, certainly where we are. And without question, I've been doing this for a while, you know, 10 years ago, interacting with people and giving talks and working with stakeholders. Those that were not quite convinced that climate change was an issue, most have changed their mind as a result of their experiences with precipitation, particularly heavy rainfalls, which we'll talk about in a minute. So this change in precipitation has been pretty profound and also impactful on how people have then experienced and thought about these other changes that are taking place. This is really the one that explains why there's you know, if you look at the various surveys of climate attitudes in the state or, you know, region, nationally, the Yale Communication Group, probably 2/3 of the population feels a significant degree of concern over climate change. And in the Northeast, there's no question that this precipitation and this intense precipitation has been what's driven that disposition, that attitude towards it. This is a generalized percent change in the heaviest 1% of events, the 99th percentile, which is statistical sort of gobbledygook to say the really, really big events. So 4 and 5 inch rainfalls in 24 hours kind of thing. And we've experienced more of them, and they do dramatically more damage than the same amount of rain, an inch a day over a week or longer. It's these intense events that really have created havoc and caused many people to try to get answers to how do we move forward, how do we prevent more of this from occurring. And if we model 4.5, the moderate on the left, and 8.5 on the right, and these two are to the end of the century, this is not a phase of climate warming phenomena that we go through. This is a trajectory of increasing precipitation, which will continue to the end of the century and certainly beyond. And so even the moderate, we expect more precipitation, significantly more, 30–40%, and at the high level of emissions, even more. I'll just take a quick detour here for a minute. I know you'll have access to the slides afterwards. For those in Maine with particular interest in Maine, we've done these reports Maine's Climate Future over the last 10, 11 years or so. Maine's Climate Future 2020, we just released just before the pandemic hit here in the US earlier this winter. You can download a PDF of it on the website, and all of the other reports are still available as well. So those who are interested in getting more information specific to Maine, by all means, please go to the website. You can just Google Climate Change Institute or Maine's Climate Future, and you would get there as well. A couple concepts relative to the change. Are these changes in climate just natural variation? Sneak preview, the answer is no. This is one of a number of different examples of data having to do with climate attribution, which has become a pretty important science unto itself. It's about how do we attribute some component of change that we see or a particular event to climate change versus it being a natural phenomenon that we would have had anyway. And it's very challenging to do, and often it's done statistically, sometimes mechanistically. And so these are examples of how that would work. And so this is going back into the middle of the 1800s. That curve right there are the observed temperatures from the Global Carbon Project. It's NOAA data. And so we see that the global temperature bumped along at a relatively highly variable year to year. That's part of our system. But overall, over time, without much change. And then early in the last century, we started to see an increase in the overall temperatures. We have computer models that they use for modeling future climate, and that's what they're using when we hear about what's going to happen in the future. And these two colors represent those models, one without the CO2 or the greenhouse gases that we emit as part of it, and then one with. And so this is the model, that's the model not including greenhouse gases, and this color is the model, that's the model including greenhouse gases. And what this tells us is up until about the middle of the last century, 1955-ish there you see on the models and observed temperature, whether you included the greenhouse gases in the atmosphere from us or not, agreed very well. And so there essentially was no major impact of these greenhouse gases. But once you get past the middle of the last century, you essentially can't replicate the climate with our models without including the human-induced greenhouse gases, particularly CO2. And when we do, then the models agree relatively well, particularly on this warming. And so we see over and over again that the argument of it may be just natural, almost all of these events will have occurred anyway, sometimes more frequently, but the intensity is often, or some other characteristic of the event, depending on the event, attributable to the climate signal that we have applied, and it's getting stronger. Can we just adjust to incremental change each year? And you've seen this plot before. Dr. Hafford showed, I think, a version of this same figure. And this is to sort of convey that this is from Will Steffen's paper back in 2015, coining the phrase, the Anthropocene, the Great Acceleration. And here's a number of socioeconomic trends, chief among them, of course, population, GDP, all of those good things. And then over here, Earth system trends, greenhouse gases, nitrogen oxide, agriculture, domesticated land, what tropical forest lost. And you don't have to read the fine details. You can just stand back and see that most of these trends are accelerating, and the data we have here in Maine, I can tell you, is the same. All of the indices of a changing climate not only are continuing, but the rate of change is increasing. And so if we're not working to address it, we're falling further behind and faster behind. This is undoubtedly too much bling, so I'm going to apologize right away. But the reason I'm showing you this is it's one of many depictions of the concepts of tipping points. And while our climate system has lots of interannual variability, climate change is the overall direction of change, but there's also step functions. There's also rapid changes that can take place. And there's a field of science in climate science, abrupt climate change, that is related to these. But we talk about tipping points in the modern system. And those are aspects of our planet that are being pressured by us. And there may be thresholds. There may not be just a continuous incremental change, but there may be thresholds that we reach that cause rapid change or irreversible change. You've all heard of some of these, certainly. You know, we're cutting down Amazon rainforest. Fire in the Amazon is causing the loss of the Amazon rainforest. Those are the lungs of the planet. Boreal forests are changing from moisture stress and some drought. The Greenland ice sheet, just in the past week, I think the report hit the press that the science now suggests that the rate of ice accumulation is falling behind the rate of melting. And so we're in a period of, or we've entered into a period of irreversible change and relative to the ice sheet. The Arctic ice, as we've already talked about, has a dramatic impact on our climate, and we're in a matter of, well, I keep doing that, a few years or a few decades, and the summer lows will lose all the ice out of the Arctic. Permafrost, permanently frozen soils in the Arctic that have accumulated a lot of organic matter, a lot of carbon. As they melt, they release that carbon to the atmosphere. And the Antarctic coral reefs, things like that we've heard. The other thing that I wanted to point out, and why I'm showing you this kind of noisy figure, is the climate scientists talk about the teleconnections of our planet. And that's what we're seeing buzzing around us here. These currents link different continents around the world. And so when we think about how does heat get from the tropics to Europe, it rides up this current along the eastern seaboard, essentially, and then goes across, leaving that energy for Europe. So what happens in one point in the planet does in fact impact other places on the planet. On an ongoing, continuous basis, because that's how our planetary system works. And so we're all in this together on so many levels. So what do we do about it? We can talk a lot about all the bad stuff to worry about, and that is the basis for the anxiety that we appropriately are focusing on. But we're going to move forward. We need to move forward, and we need to have things to both show and tell our children, as well as act on ourselves. And so I'm going to step back for a minute here, talk about the IPCC. You've probably heard of the Intergovernmental Panel on Climate Change. It's from the United Nations Environment Program. These are the groups of scientists, or a group of scientists that are brought together, very big group of scientists that are brought together on roughly a 6-year basis, 5 or 6 year basis, to do an assessment of climate on the planet. And I won't go into this in great detail. I show you this to point out that they've been doing this since 1990, and we knew what to do in 1990. We knew what to do relative to reducing greenhouse gases, and we knew a lot about what to do on how to adapt. We've gotten a lot better at knowing what to do over this time frame. So in 95, 2001, on up to the most recent IPCC assessments were 2013, the first report, and then in 2014, the rest of them came out. They usually come out in a set of reports having to do with the physical basis and then sort of what we do about it. Point being, we have a lot of information. We continue to progress undoubtedly, but there's no mystery that of what we need to do, the consequences of what we don't do so far, and how we need to move forward. After the Paris Climate Convention that this group held, and the Paris Accord, the agreement, they asked the IPCC to do this report that they came out with back in 2018 now, Global Warming 1.5, to look at what was the impacts of a warming planet that would warm 1.5 degrees centigrade. And we hear a lot about keeping us under 1.5 degrees centigrade. We've already warmed about 1.1 degree. And so we're certainly moving along. You see it on this curve. Here, this is the actual temperature, average temperature of the planet. And so that's the smooth curve. And this is the 2017 point. Obviously, the trajectory we were on was continuing to increase. And we need to bend the curve. This curve is the temperature curve, not the CO2 curve. The CO2 curve has to essentially collapse in order to keep us under 1.5. If we fail, then we're very likely to get to 2. If we do almost nothing, then we're going to go to the temperatures that we've seen in Fahrenheit later in this century. This is where you may have heard that we need to address global warming or climate change by 2030. That's because in order to meet this target, we need to reduce greenhouse gas emissions by about 45% from compared to 2010 levels by 2030. So if we're going to reduce by 2030, 45%, that doesn't mean we have 10 years. That means, you know, we're behind the 8 ball because we're not working on it vigorously enough yet. And so there's much to do. And of course, we keep breaking records of highs of greenhouse gas emissions. That's different from temperature. We break those records as well. And this year, because of COVID, there was a dip in greenhouse gas emissions, but emissions are not concentration. And so this year, like last year, we will break the record for higher global CO2, and we've never reversed that. You would have to have a COVID, which obviously I'm not suggesting. You would have to have something that did what COVID did to reduce emissions every year, year after year, in order to bend the curve and to start to see the kind of targets that we were talking about. And this is, you know, some scary statistics kinds of things to show the difference between 1.5 and 2 degrees centigrade, which they asked the IPCC to do in this Global Warming 1.5 report. And so at 1.5, we lose Arctic sea ice. Huge portions of the population are exposed to heat waves, drought, continued extinction of vertebrates and plants and insects. Coral reefs will continue to be bleached and die. Populations exposed to sea level rise, that's what SLR is sea level rise flooding, are, you know, millions of people. And we are potentially going to avoid the worst of tipping points contributions by keeping it to 1.5. If we slide to 2, then a lot more of this happens, and you can see the numbers, and you get the point of what they are conveying. And keep in mind, right now we're on track for the end of the century for 8, and so we're well ahead of the curve relative to greenhouse gas emissions. So I talk about that to emphasize the aspects of the crisis. There's no time to wait. If we think we've done a little bit, we haven't done nearly enough. But part of what we do about it is these two concepts, adaptation and mitigation. Adaptation is what we do to minimize the negative impact that changing climate and other ecosystem degradation is having. Mitigation is what we do to reduce essentially greenhouse gas emissions. Mitigation is sometimes used in different ways by different sort of disciplines. Adaptation is pretty much used in this regard. So if we're going to limit greenhouse gas emissions, we talk about mitigation. If we're going to invest in making our systems more resilient, we talk about adaptation. And you could divide the world in various different ways, but this is my little wheel of misfortune in how to divide up different sectors of the environment, of our economy. And so I talk for an hour about any one of these orbs, and you can divide it differently, and there's other things that are certainly missing. But the point here is, for any one of these, we can go at great length to talk about how both what happens within them is influencing greenhouse gas emissions and things that we can do to adapt to minimize the negative and to prepare for what is to come. And in some cases, it's to be able to thrive, but under a different set of management or a different species. In other cases, it's how we protect ourselves from the negative. And usually I make disparaging comments about those critters, the ticks and Lyme disease, and that just continues to be more and more of a concern. So people have questioned about anyone specific. I won't get into the details right now, but the point is climate change is not the only thing almost ever, but both adaptation and mitigation aspects of climate change pervade all aspects of our lives. And you're adapting a lot of times, even if you're not doing it thinking I'm doing climate adaptation. Years ago, I started to say in talks, if you mow your lawn earlier in the spring, you're implementing climate adaptation. And so that's obviously a trivial example of a lot of really important things that we do and that we're learning about. Climate adaptation often will follow this kind of model or framework. The cycle of climate adaptation, preparing, depending on the source that use it, they'll use a little bit different language, but basically it's preparing your situation for adaptation, assessing, these are the important ones now, assessing your risks. Where are you most vulnerable? Where are you most exposed? Identifying your adaptation options for those particularly important risk of high risk situations. And then once you've identified what those options are, which is an important step unto itself, then you assess them relative to their suitability. And some of that is economic, cost effectiveness. Implement the plan and then evaluate, monitor, measure what the response is, and obviously that then feeds back into the cycle. And there's programs in human health and agriculture, and or you name it, fisheries, community resilience that follow this kind of cycle. And so this is something that we're doing, and we're going to do a lot more of going forward. So probably my favorite slide in the talk. Why should we be hopeful after all the sort of gloom and doom? Well, we should be realistic, but I do think there's reasons to be hopeful, and I have three. One is that modern society can change fast. We've taken quite a while to get ourselves into this mess, and we have the 7.2 billion people on the planet with us now that are going to have to be all part of the solution in some way. But we can see many examples where it's remarkable how fast we can change as a community, as a country, as a planet. Haber-Bosch are the folks in Germany that invented or discovered how to capture nitrogen out of the atmosphere and make fertilizer. And probably 2 out of 5 people on the planet are here because of the food we've been able to produce by that fertilizer. Lots of environmental issues around agriculture. I got that. But nevertheless, that transformed rather quickly. And we've lived some of this, internal combustion engines, computers, the internet, stupidest thing in the world, corn ethanol that the government promoted in the 2000s because it really didn't save carbon either at all or very much, and it really messed up the food systems and conservation practices, what have you. This slide predates COVID. Now I don't have to convince anyone that the world can change on a dime. In months, we've changed all aspects of how we live around the planet. And so, practices and leadership that gives us a direction that we implement policies for change can change the way we behave and how we function really quickly. And that includes climate change, greenhouse gases, and their effects. So that's number one. We can change quickly. We don't have to take 100 years getting out of this. Number two, we absolutely know how to fix the problem. As I said, in 1990, we did when the first IPCC report came out. And most important, what we hear about with air pollution over and over again, particularly by industry, is that it's going to wreck the economy. It's going to cost too much. It's going to cost them on a short term too much. That may be true. But time and again, we see that it does not cost to use science to inform policy that implements smart regulations on air pollutants. It pays back, particularly if you include the human health benefits, which you have to, it pays back many times over. So it's a false argument that the policies that will limit greenhouse gases, the Obama carbon rules, for example, would not have been a net cost to society over different periods of time. And this has to do with the social cost of carbon, which gets complicated. But nevertheless, it's not a net cost. We've seen it for lead in gasoline. We've seen it for mercury. We've seen it for acid rain. And it's the same with climate change in the US and beyond. This is from the National Climate Assessment showing, you see these different colors are showing us that at the different scenarios, so as you go from that color to that color, so as you climb up this curve, it's the amount of temperature change that they drive, and we sort of saw those kinds of plots already, and the percentage of the US gross domestic product that is sacrificed because of the impacts of those changes. So there's lots of information that demonstrates the cost effectiveness of change. So that's the mitigation part. Cost effective climate adaptation informed by science is always way better than denial adaptation after the fact. And a lot of times you see benefit cost ratios, 3, 4, 6 to 1, sometimes more, again, meaning for every dollar invested, you get paid back more in the things that are avoided, the negative things that are avoided. I have this quote down here: the best way to predict the future is to create it. I like it. There's a bunch of people who have said it in slightly different versions. President Lincoln was one of the earlier ones. But the point is, we have a lot of control over how we move forward and the future that we expect. We can't predict the future. We don't know what the future will be, and we're creating it right now. This is a little plot that you may get right away or not. We don't need to spend time on it, but this is from Swiss Re, and Munich Re and Swiss Re are two major reinsurance companies in the world. Reinsurance companies insure the insurance companies. And so the insurance companies are obviously out there very concerned with what they insure and how disasters impact their bottom line, and they do big time. But they too carry insurance, and they buy that insurance from these folks. These folks have been, no matter who is in office in what country, These folks have been evaluating in a very sophisticated way climate change risk and strategies for adaptation for a long time. This is from one of their reports, and basically this is the $1 line, and so these are various adaptation measures. And why I like it is it's simple-minded. I tend to be simple-minded, and so if the bar is above $1, it pays you back more to invest that dollar. You're going to save more money. If the bar is below $1, then you can still do it, but it's a personal choice, and it's not, from an economic standpoint, going to give you an economic benefit that's more than the investment. And so when we do these adaptation evaluations, we're looking for what are the priority adaptation measures to invest in, and then depending on the situation, the ones that are really strong, that's the low-hanging fruit. That's where we should start, and they're waiting for us to begin. So I think we should have reason to be optimistic, because we can change quickly. We know how to mitigate, and it's not going to cost money. We know how to adapt, and in the long run, it's not going to cost money. We have to figure out in upfront costs and how to find those resources, identify those resources, and how to implement those practices in a socially just way, which we're not very good at doing too often. But we're focusing more on it now, which is a good thing. What should I do is a question people often ask me personally, what should I do? And I'll be very quick with this slide. There's no question the one thing you can do, and I won't get more political than this, but is vote. And I mean that very sincerely. People ask me all the time, and students ask me what's the best thing that I can do? Well, the first thing we can do is vote. That's going to have the biggest impact on policies going forward. In the 2016 election, 60-some% of us voted. A lot of people stayed home. The 18 to 25-year-olds, it was less than 50%. And so we can change these policies that have the potential to change our trajectory quickly, but we need the right leadership in order to do that. Show up for, we're here tonight. Show up to express your support for policies and public protests and public gatherings. I shouldn't just protest, but public gatherings, to convey. Tweets are great, but I'm not, it's when we see people in crowds, hopefully socially distanced for the near term, expressing their passion for this issue. That means they bothered to get there, to be informed about it, and they have something to say, and by their presence they have something to say. And then lastly, people have a lot of anxiety over personal behavior. I don't live in a tree hut and walk 40 miles to work. I think we all should be mindful and informed about the impact our lives have and a carbon footprint of what we eat and how we purchase things. But do what we can in a reasonable fashion, being mindful of those that are less fortunate, but really emphasize the other ones. Show up and vote, and we can get the policies moving that we can participate in. Sort of wrap up, climate change and COVID, how are they, how do you compare them? This cartoon has made the rounds, and for us climate scientists, it sort of brought a smile to our face, obviously in a very, very sad way. But, we've gone around, if you can't read it, these are two scientists in front of the climate science door, and then these are two scientists in front of the COVID-19 science door, and one of them saying, as long as we just provide the facts to the American people, presumably they'll do the right thing and we'll move forward. Well, certainly we haven't done that in the United States this year, and we haven't done that relative to climate. And so these two folks are laughing, but the reality is we've got to go beyond the science, and we have to do the kinds of things that we're talking about in order to make change. But we know how to do it, and we can do it, and we can do it in a meaningfully, timely way. Comparison between the two, I just ran out a list here. Science-informed decision-making. Use science to make decisions. We see it with COVID, we see it with climate change, period. It's cost-effective, it makes a difference, it's successful. No nation's an island. A pandemic went around the world inside of a couple of months, and climate change we're all a part of. Both of these reveal the vulnerable systems that we have on lots of different levels, and we see in the news every night, some of it for climate, a lot of it for COVID right now. And a lot of it are the same systems that are applied to both, from food systems to health systems, social systems, and political. We've already said social inequities are magnified. They're not separate issues. Time is not on our side, however. We are in a transitional period. I passionately believe that. We're all waiting for the vaccine. Obviously, the Russians think they have it and they're off and running, but we'll see. But nevertheless, we should be hopeful that we'll have a vaccine, and that will be an important tool to manage this pandemic and public health going forward. But we're not there yet. It's a marathon here this year, not a sprint. But that is fundamentally the vaccine for, it's a real vaccine for COVID-19 that we're looking for. We don't have a vaccine for climate change. And I'll close with, in Maine, this is what a vaccine for climate change might look like. In the past year, the governor has established a Maine Climate Council. Co-chairs are Director Pingree and Commissioner Reed. But the point being is, here at the state level, and I've been involved with the climate activities in Maine for decades, we relatively quickly assembled the troops, you might say, and the Maine Climate Council built something like this. There's 39 members of the council that are meeting to come up with a new climate action plan for the state by this December. And since last September, there's been these 6 working groups and a science and technical subcommittee. Over 230 people have been involved in digging down in a lot of the things that we talked about to figure out what are the strategies that make the most sense. How can we bend the curve and limit carbon emissions? The governor has carbon neutrality set for 2045 and 80% of the gross greenhouse gas emissions reduced by 2050. So we have a very aggressive targets that meet that are parallel to what the Paris Accord was calling for. But also in this is a lot of activity having to do with building resilience, from communities to our food systems, to forests, and our wildlife and biodiversity. It's not as simple as a single shot, but this is what a vaccine for climate change looks like, and it persists going forward. Every 4 years, there'll be an update to this climate action plan. So I'll stop there and close with this, if anyone reads the New York Times and familiar with Tom Friedman, the columnist, and he took this from a fellow named Hal Harvey, who I don't know, is a CEO of energy innovation in California. Friedman wrote the article proposing that this should be Joe Biden's banner if he was nominated to be the Democratic candidate. And I don't think Vice President Biden has grabbed onto it, but I have. And so I think it speaks volumes. Respect science and use science. Respect nature, because we're not separate from it and we're harming it. And respect each other as we go forward. So with that, I'll stop and happy to take questions.
Thank you, Dr. Fernandez. Do you want to discontinue your screen sharing?
Oh, yeah.
And then, you'll.
Mm-hmm. There we go.
Thank you so much, Dr. Fernandez. My name's Leslie, and
Hi, Leslie.
we have a number, we have a number of questions in the chat, and I've been scrolling through them while you were doing your talk. And honestly, I think, a lot of them actually were pretty well answered as you started to go along, especially about the CO2 emissions and about the warming of the oceans. But there's a couple at the end that I think maybe would seem a little apropos, kind of drawing things up. One of the people in the audience is asking, what's the most important sector of Maine's economy that an individual could address through their personal actions? They listed diet, transportation, housing.
That's a good list. Overall, Maine, the biggest sector of greenhouse gas emissions comes from transportation. Of course, if you don't drive very much, then that's not probably the priority that you personally should address. We have a big impact with our diets, certainly, and probably everyone's heard about concerns relative to meat and cattle, and those are real concerns. Plant-based diets are much lower in greenhouse gas emissions. And what was the third one that you mentioned?
The third one was, hang on just a second.
I think like home insulation.
Housing.
Yeah. Energy efficiency in our homes and our structures, new structures, but certainly more importantly, even the old structures, of which we have a lot here in Maine. That's kind of low-hanging fruit. That's a really important first step. It pays back typically in the energy savings for the homeowner. Which one's most important depends on the person's situation. If they live in a big old rambling farmhouse, but they work across the street, then energy efficiency is most important. All of those are the top of the list. There's probably, it's not really a direct answer to that question, but we hear about things that we can do relative to conserving, which are definitely good. We also hear about things we can do, biofuels and the natural climate solutions of growing forests that take up carbon as ways of contributing. All of those have potential, but the most important thing and the bottom line that's essential is to essentially eliminate fossil fuel combustion. My rule of thumb, a lot of times we get into these very complex discussions and about different aspects of what we do that will contribute. And then sort of not my rule of thumb, what am I looking for? My baseline is, what does the atmosphere see? And so there's things that we can do that might make us feel good, but if ultimately it doesn't change, if there's leakage, if we don't do it, but that means someone in Pennsylvania does, then the atmosphere sees the same amount of CO2. So in Maine, overall, if we drive less, if we do everything we can to electrify our transportation system, that's going to have a huge impact. It's a big challenge. We need to both produce the power, but the electricity, and then distribute it. All of that is before us. But we can do that, and we can electrify transportation. Each of us obviously makes decisions on what we eat for various reasons, and I think the health specialists usually are better at scaring people about what they eat than the climate scientists. But nevertheless, we do have a tremendous impact. We really have a big impact just on food waste. We waste a tremendous amount of food. Only a minor portion actually does what it's intended to do, and yet at the same time we've got burgeoning hunger in our state and throughout our world, of course. And then when we have things like COVID or disruptions like climate will give us, we end up with these bizarre situations of dumping potatoes and pouring out excess milk because it can't get to where it needs to go because our systems are so structured to be inventory controlled and centralized. So to the extent that we can eat more plant-based, support local production, be mindful of waste, that would have a very significant impact.
Thank you very much, Dr. Fernandez. I think that pretty much wraps up the questions.
Okay.
And thank you. I think we would all love to keep you for another half hour, Dr. Fernandez. But we are so appreciative, and I think we're so fortunate to have you with us here tonight. Your presentation was fascinating. The slides were outstanding. And for me, I just think that you have such a conversational way of relaying complex information that makes it easy for someone like me who's not a scientist to understand and to grasp the immensity of the problem. And for you to end up, with hopeful notes that you did was so meaningful. So just thank you. It's just wonderful. And I know everyone here joins me in thanking you as well.
Well, thank you all. I see there's 41 people here that could be doing something different at 6:30 at night. So I appreciate that you're taking the time to chat with me about this.
Yeah, and as you said, everyone is showing up. So vote,
right,
show up.
Exactly.
Yeah,
Vote,
yeah.
show up.
Yeah, so thank you everyone here for showing up. And before you leave, I'm going to share a final screen that has information for Dr. Fernandez and a few other bits of information about our next class. So I'll leave that screen up for the next 15 minutes or so people can grab that information for themselves. And to repeat that, we have recorded this presentation, and we also have Dr. Fernandez's PowerPoint, and they're available on the recording page. There is a link to that page in your email notice with the Zoom information for this class. So if you go back to that email, you'll be able to get the link and get the recording and the PowerPoint. So with that, I will say good night to everyone and take care. Thank you all.
Thank you. Thank you.
Thank you. Thank you all.
Thank you.
Bye-bye. Thank you.
Namaste.